We'll start a couple minutes early if we have Tim Crumbley on. So Tim Crumbley from NASA OSMA. He will be giving us a talk on NASA's software safety critical approach and requirements to support critical NASA's missions. Tim.
Yes, I'm here. So let me get started.
All right, we can see you and we can hear you. Thanks.
Great. So yeah, first of all, let me thank all the organizers. Y'all done a great job with this thing. Really appreciate it. It's not easy to put together a virtual talk with this many people. So thank you. But let me get into this discussion. And here's kind of the thought process that I want to lay out for people to think about. And the first really kind of question, I'm not looking for an answer per se, but I wanted to at least get you thinking about it throughout this presentation. So what do you think should be done differently if the software you're developing is safety critical? In other words, a mistake in that code could potentially harm/kill somebody. What do you think should be done differently? How should that be approached? And how is that approach today in the way we're doing business? And then another way to think about this same question is, if you are dependent on that software, and or if you're working with a system that is controlled by that software, what do you want to make sure got done on that software prior to it being used? And it is a higher standard than like mission critical and some of the other areas we deal with. Now, I know a lot of the spacecraft that we're talking about in the last couple of days are basically unmanned missions, but we deal with both manned missions and unmanned missions, and a lot of our unmanned missions are critical and have hazards associated with them while they're on the ground during the testing phase. So that's one of the questions that we've been looking at the agency lately, is how do we do this and how do we improve the way we do this, and what really needs to be done that adds value to the activity. So with that, I'm going to go ahead and get started. Next chart, please. So we've recently updated. We used to have a software assurance standard and we had a software safety standard at NASA. We've taken both of those standards and combined them into a single standard, now titled the NASA Software Assurance and Safety Standard. It's available out there, publicly available to anybody that wants to see it. It is directly tied to and relatable into our software engineering set of requirements. So in other words, you've got the software engineering requirements in our NPR 7152. And this is a one-to-one relationship saying, what are the assurance and safety steps needed to go along with the engineering activities that are supposed to be done? This is a very performance-based standard. It ties directly to the engineering standard, and it lays out a number of steps needed to make sure that we have good, safe, critical code done correctly. So with that, I'm going to keep going to the next slide. So what are some of the things that we actually do in this new standard? Number one is, what is safety critical code? How do you determine that? We do a lot of mission critical code, but what is truly safety critical code, and how do you go through that process? In our previous system, we had a very broad definition for safety critical, and it turned out almost most programs fell into what was safety critical code. We've kind of narrowed that scope a little bit, and we've tied it much closer to the systems analysis side of it, which is the software is classified as safety critical if it meets at least one of the following criteria. And that is, it causes and contributes to a system hazardous condition or event. In other words, this says the software needs to be called out in a hazard analysis activity. Does it provide control or mitigation for a hazardous event? Does it control safety critical functions? Does it mitigate any damage of the hazardous condition or event occurs? And does it detect, report, takes corrective actions if a system potentially reaches a potentially hazardous state? And again, this is all tied back to the way we do hazard analysis, identifying what are the hazardous activities on our given system. And this includes a look at both hardware and software. There may be hardware techniques that are built into the system that would have never allowed the software to get to this point. And if that's the case, then it's part of the hazard analysis that goes on. But again, if the software turns out to be a part of that, then it does turn out to be safety critical. So, okay, so you go through that process, you determine that your software on your particular program or project is considered safety critical, or part of your software is considered safety critical. What do you need to do? And that's the next chart. What I'm going to do today is I'm going to kind of summarize. I'm going to hit some of the high points that have been added in and changed. There's a number of analysis activities. There's a number of steps that go on. And anytime we deal with safety critical code, and this is no means a list of every one of those activities, but there's some of the things that we think are important and key going into this. One of the things we got to make sure is that we have the right safety constraints, controls, mitigations, and assumptions documented in our requirement specifications. Again, if you don't have that level, you're never going to be able to get to the point of being able to verify and test it. Also, we expect people to test the software requirements that trace to the hazardous events. And this gets into the item number 3, which is we would like to have hazard analysis directly part of your traceability, so that we can see what software requirements are interacting with which hazards. And from that, then we can identify which software requirements really should be tested. So we're looking for you to run a test on those requirements as opposed to, say, an inspection or a demo or some other technique that allows you to sell them off. And again, if there's a particular case where this can't be done, there are options, and we'll get to tailoring side of this in a minute, but that's the guideline going into it. The next chart, please. Another key thing that we're looking for is if a project has safety critical code, that we implement a series of kind of design practices. There turns out in the engineering document, there's a series of A through L, I don't know, 15 or 20 different design practices that are expectations that those design practices are included in your requirements and your design and your architectural approach. And part of our analysis is to go in and check and verify that these are or are not included. Now, again, if you have a rationale or a reason why something cannot be done, that's fine. But part of this is the intent here is to lay out the design practices and have a discussion and an understanding and understand the risk associated with not meeting any of these design practices and why those design practices can't be met with the way we're doing our design on our program and project. So next chart, please. These are some of the new stuff that got added in. So then we sat back and we said, what else do we need to do other than nominal design practices? Nominal being very good engineering software development activities. And one is confirm 100% code coverage for the safety critical components. So in other words, if you have something that's identified as a safety critical component, we need to go in there and make sure that we test it completely. Test all the options. And again, this gets back to the question that we asked at the beginning, which is, would you want to rely on, if it was your life, your family's life, or somebody else's life, on code that was not completely tested 100%? Now, we realize also that there are sometimes situations where we can't completely 100% test all the code in a safety critical component. But again, part of this is the driving force behind this action is, first of all, to try to do 100% code coverage testing. But if you can't, to understand why you can't, why it doesn't matter that you didn't, and also what other techniques have you got in place to ensure that that code that you could not test for whatever reason is correct. So you have that out, but primarily we're looking for people to look at the code coverage associated with any components in their system. And again, there's a lot of rationale. We recommend you using MCDC approach for doing that. But again, the requirement is to do 100% code coverage testing. That's one of the new things that got added into the new standard. And then the next chart, please, has another area that we added in. So we did a study recently through the NASA Engineering and Safety Center where we took a look at both code coverage and cyclomatic complexity. And the cyclomatic complexity number is how do we make sure that those safety critical components are not overly complex and difficult to test and verify. So the intent here is to confirm that our safety critical components have been designed such that they have a cyclomatic complexity value of 15 or lower. And if they're not, why? And how do we understand that? And how can we ensure ourselves that with a higher value that we actually can do back to the requirement on the previous page, 100% code coverage. But we to put this in here, really, it helps us limit the code complexity. It limits the number of test cases required to be able to verify things, make sure that we got every path covered. It's also a maintainability, and it's also an understandability question. And it gets into the reliability of that particular piece of code. So what we're looking for is very simple code that can be verified and tested and ensured that it's correct for those pieces that are considered safety critical code. Let's go to the next chart, please. So those are some of the general things, but then we got this other set of, this is actually out of the guidelines, a whole series. I won't plan to go through every one of these, but I put them in here just for informational purposes. I mean, there's a number of other things that ought to be thought about, fault tolerance, good programming languages, secure programming practices, defensive programming, the complexity, the maintainability. The bottom one down here is interesting. We've run into a lot of cases recently where we're starting to see that our software peer review processes maybe aren't as good as they ought to be. And partly it's because we don't always include the hardware engineers as part of our code walkthroughs to make sure that the software is actually controlling the hardware the way the hardware is designed to be controlled. And sometimes that can get lost when you're only dealing with the requirements and ICD information floating back and forth. So there's a number of other things over here that there were just good recommendations for what ought to be done when you get into safety critical code. So let's go to the next chart. So what happens? Okay, so you get all the way through this process, you get to your safety critical code and you can't meet 100% code coverage, or your cyclomatic complexity is 16 or 17 as opposed to 15, or 20 as opposed to 15. We do allow some tailoring of these things if it makes sense. And again, a large part of this discussion is to put these things on the table and have a discussion about them and make sure they make sense for the environment and the project that we're working on. And in some cases, it may make sense not to do these activities the way we laid them out, but at least you're having those discussions ahead of time. You're having that conversation, you're making sure that we've got the right things included. We're going through there. So we can tailor these things. In our world, they generally go through the engineering and SMA tech authorities for approval to make sure that what you're tailoring out is acceptable from a risk perspective on that project, and also a risk perspective from the hazard analysis side of the house. Let's go to the next chart. Now, we got a lot more information about all this in terms of implementation, guidelines, suggestions, rationale in our handbook. The handbook's also available out there to the public. Gives you a lot of guidance for these activities. We're continuing to work and improve our handbook. We're moving some of the material that's in our old NASA safety guidebook into the handbook and trying to enhance it to give you things to think about and look at and consider when you're developing this type of code, or any type of code for that matter, even mission critical codes. It's a good technique. The handbook allows you to see what the requirement is, what the rationale is, what the guidance associated with it is, what are the software assurance associated with it, steps need to be, what the guidance for the software assurance needs to be. So it's a good resource for the engineers to take advantage of and look at. let's go to the next one. So yeah, I left some time for questions if anybody's got any. And again, additional information can be found at the website, and feel free to look around, particularly in the handbook is probably a good source. I think it does a better job of explaining what the requirements are and why the requirements are what they are, and the rationale and the guidance for implementing those requirements, than say just picking up a NASA policy document and reading it and trying to figure out why is it written the way it's written. So take advantage of that and take a look at it. With that, I will open up for questions.
All right, thanks, Tim. We do have a couple of questions in the Q&A and in the chat. First one from Jacob Hageman. I've heard MCDC as frequently being the gold standard for code coverage, but there are not open source tools. Readily available that I know of. Is there a NASA tool or some other resource available?
I'm not real sure about the question about whether or not there's open source tools available or not for that. There are available commercial tools out there, and we do have NASA resources available, and there has been different techniques used. So without getting into specific tools and specific tool vendors, yeah, I think there are.
Okay. All right, next question in the Q&A from Matthew Benson. How do these standards address generated code? For example, how are maximum cyclomatic complexity standards applied to generated code? MISRA just exempts generated code, but does not address the models. At what point are the source models that generated code under, generated the code under the same scrutiny that hand-generated code is now?
We actually treat them from the purposes of requirements. We treat both generated code and hand generated code the same way. They both have to apply to the same set of requirements. They both, the models generate source code that could then be run through analysis tools and looked at. And if it's not, then you have to go back and modify your model. So yeah, we treat them the same way. We don't have an exception for auto-generated code.
Okay. Next question from Justin McNeil. He asked if the NASA software classifications have changed.
When we updated the NPR about a year or so ago now, year and a half, the only real change in our classification standards was in the institutional software arena. We used to have class F, G, and H, and we've now rolled that all up into class F software, but it's all in the institutional side of the house. The mission side, which is class A through E, not really, it has not changed. We always try to add a little more detail in there to make these kind of situations that we run into throughout the implementation process where we end up with questions. We'll add a little more guidance material to help people better understand and interpret the guidelines that are put in there. But no, class A through E are still the same as they've always been.
Right. Next question from Leonidas. How would you say the standard compares with DO 178C?
It is close. We looked at DO 178C. We looked at ESA's standard. We look at the IEEE standards. We look at a number of different standards whenever we update our standards and look at the different parts of those things. So yeah, I think it's very close, very similar approach to what's in DO 178C. But again, DO 178C is a FAA a different approach from a insight perspective than what our standards are written from.
Okay. Next question from Mark Johannes. Do you map software assurance cases or safety cases to high-level assurance cases, perhaps from system engineering based ISO IEC 15026?
We don't, well, I won't say 100%. We don't do it. We don't currently do it. We've got an activity going on through our software safety lead at OSMA looking at safety cases and how safety cases applied. I think we're going to get there in the next short while, but currently we don't necessarily do that on very many programs.
Right. Next question from Tucker Taft. He asked if there are languages that are considered safe by NASA.
No, we do not dictate language selections. We do have known tools and capabilities in certain languages, but no, we do not say one language is safer over another. No, we are starting to look at secure coding program languages, but no, we've not. We do think there are certain features in languages that are safer and than others that aren't, and we get into that in some of the guidance material, but no, we don't normally dictate a language selection.
And maybe to ask the question differently, are there languages that NASA considers unsafe?
That is a good question. Not that I know of. I'm not saying that they don't exist. We might have to go look at it if you came up with it. I mean, that's part of our upfront evaluation process is what languages are we selecting to use and why.
Okay.
And what's driving that selection.
All right. A couple more questions. Another one from Jake Hageman. I think relating to the earlier question. I've seen cyclomatic complexities of 40 plus in heritage flight code. Have you addressed the trade of fixing such complex code that passes all testing and has been proven, and which could introduce bugs versus leaving as is?
That's part of the challenge here is to go back and look. I mean, heritage code, yes, we know there are some out there. The real question becomes then is let's go do that risk trade. Let's look at why is it as complex as it is, and how can we ensure ourselves that it actually does test all of the cases that are in that code. So yeah, that's part of the reason why the requirement's in there, to get us to go back and think about and look at those questions, and then also look at why is the code written the way it is. And in some cases it makes sense to leave it alone. In some cases it doesn't, but that's the trade-off. So it's hard to say in a generic sense, but yeah, that's the reason why the requirement's in there, to get us to go back and focus on those questions and look at them, because the requirement didn't exist before. But it does now. And in fact, there's an activity going on right now to include both of those requirements in the engineering document in 7150.2. It will get updated here in the next year with the requirements being added in there from an engineering perspective too.
Okay. And another question.
I know I didn't completely answer your question there, but that's the whole purpose of it, is to go look at this kind of stuff.
Okay. All right, next question from Leonidas. Do the standards include guidelines for tool qualification?
The standards include a requirement to accredit tools, depending again on where and how those tools are being utilized in either the development cycle or as part of the onboard flight applications. So we got different levels of accreditation and qualification of those tools. And that's been in the engineering requirements for a long time. And our standard just talks about how the assurance side makes sure that that gets done as part of the process.
Excellent. All right. Are there any other questions for Tim while we have him? We've exhausted those that are in the Q&A and in the chat.
Sounds good.
People another opportunity. Anybody? All right. If not, thank you so much, Tim. Excellent talk. And of course, people can continue these conversations on Slack.